Hi everyone, it's great to meet you all. Myself Valarmathi, Assistant Professor, Department of Information Technology in S.A. Engineering College. Today I am going to discuss about the topics of IPv4 and fragmentation in computer networks. Welcome to the session. First you will see what is IPv4. That IPv4 is the fourth version of the Internet Protocol. It holds the addresses of the in 32-bit integers. It is expressed in hexadecimal notation. For example, 192.0.2.156. It is the IPv4 address. The value is in between 0 and 255. We can write any values. This protocol works at the network layer ASI model, whereas in TCP/IP it works at the internet layer. Its responsibility is to identify the host based on the logical address, and it routes the data through the networks. Next thing, the Internet Protocol version S4 uses the 32 bits logical address. The basic idea behind the IPv4 frame is the IP packets is encapsulated the data which is received from the transport layer, and it appends the own header informations, and it is done in the network layer. This process information is forwarded to the data link layer. The data link layer makes the frame, and the frame format is IPv4 frame. In this, the frame we have the header, minimum size of the header is 20 bytes, whereas the maximum size is 60 bytes. In computer networks, basically we have two types of internet protocol. One is IPv4 and the another is the IPv6. IPv4 is whatever we say in the section is IPv4. IPv6 is the future version of the IPv4. That is, suppose if you are running out of the IP addresses, at that time IPv6 will dominate the IPv4. Next thing is, you will see about IPv4 framework. In this IPv4 framework, from version to destination address, it occupies 20 bits. That is, it is mandatory. Then after the destinations, we have the IP options. That is, IP options, it's an optional field. Its size is 0 to 40 bytes. The overall header of this packet is 20 bytes plus 40 bytes is 60 bytes. Then the maximum size of this header is 60 bytes. The next part is the data field. In this data field also we can say it as a payload. Next you will see all the fields in detail. First field is the version field. Version is it defines what version this given packet is. For example, if the version is mentioned as, then the given packet is, the given frame belongs to the fourth version, that is IPv4. If it is 0110, it belongs to the version 6. Next field is IHL. IHL also we can say it as internet header length. The length of this entire packet only will found out. That is, instead of find out the entire length, we will find out only the header length. The minimum size of this header length is 5. We already say it is a mandatory. That means it is a compulsory field. It's having the 20 bytes. That is, how will you find the header length? The header length is found by the multiple of 4. That is, 5 into 4 is equal to 20 bytes. We already know that it is the minimum size of the header length. For a maximum size, it contains the 4 bits. That is, in 4 bits all are 1 means, that is 8, 4, 2, 1 equal to 15. 15 into 4 equal to 60. The size of this maximum of header is 60 bytes. Next is, for example, if I given if IH is equal to 12, then header length is equal to 12 into 4 equal to 48. Next one, we will see the type of services. Type of services, it defines the what type of services providing. It completely mentioned this byte completely mentioned the type of services, but practically it is defined into bisects into two parts. One is DSCP and then ECN. DSCP is differentiated service code point, and the ECN is explicit conjunction notification. In this 8-bit, first 6 bits only occurred by DSCP. It defines the type of services for a given packet. Then it by default it contains a 6 times 0. That is, no priority is given to the packet. If from services the priority is given, based on the priority routing will be happen. For example, voice over IP and video chat. In voice over IP, majority of the companies are preferring voice over IP rather than GSM, because in voice over IP along with internet this is happening. So the routing is, you cannot delay in sending the packet in the routing. The routing is given at the highest priority. Next, video chat. Video chat is also given at the higher priority, so that we cannot delay in sending the frame. Next field is ECN. ECN occupies the next last 2 bits of the type of services. It is used to notify the congestion which has occurred in the type of services. And also we can say if a network is overloaded with large number of data, at that time this comes into picture. Next is the total length. Total length occupies the 16 bits, that is the last of the first row. In total length, it occupies 2 bytes, that is 16 bits. It defines the total size of the packet, not the header, whole packet. That is the header plus data will get the total length of the packet. The maximum size of the packet is 2 to the power of 16 minus 1, that is 64 KB minus 1 bit. The minimum size of this packet is 20 bytes. We already say it is a mandatory, it should be 20 bytes. Next, we will see about the source and destination address. Each source and destinations occupies separately 32 bits. The source address contains the IP address of the source host. The destination address contains the IP address of the destination hosts. Next field is the option fields. The option fields contains the bytes in between 0 to 40 bytes. It may be anything, but it is intimated by the IHL. Based on the IHL, it will be vary. Next thing is time to live. We also say it as a TTL. TTL occupies 1 bits, that is the 8 bits. It is also called as an hop counter. It is used to avoid the infinite loop in a networking, because at the time every packet is assigned with some set of values for TTL. After every hop, the value is decremented by 1. If this process is repeated, at the time when it reaches the 0, this packet is discarded. For example, in host 1, I am sending the packet value of 255. Then after crossing this router, it will be decremented to 254. Then it crosses this router 2, it will be decremented to 253. This process will going on until it reaches the 0 value. Once it reaches, the packet is discarded. Next thing is protocol. Contains 1 byte, 8 bits, which is present in the transport layer. But in transport layer, we contains all the details about the protocol, whereas in network layers, it contains only protocol numbers. For example, 1, 6, 17, anything based upon the protocol number, we can identify which protocol this packet belongs to. For example, TCP, the protocol number is 6. For UDP, the protocol number is 17. For ICMP, the protocol number is 1. IGMP, the protocol number is 2. Next field is header checksum. Header checksum is used to check whether the packet is transferred without any error, only for the header, not the entire frame. After every router, or we can say it is after every hop, this recalculate the checksum and it is updated in the header checksum field. Next is the identifications. Identification is used to identify the fragmentations. It's given a unique ID to the given packets. If a packet is fragmented during transmission, if all the fragments should contain the same value, then only we can able to identify the original packet, which packet it belongs to. Next, we will see about the fragment offset. Fragment offset tells the exact position of the fragment, where it is in the fragmented. Next thing we will see about flags. In flags contains 3 bits. As if a packet is too large, at the time if the flag tells whether they can be fragmented or not. Based on this, in this 3 bits, first MSB is the most significant bit is always said to be 0. That is the first bit is 0, it is for reserved. Then second bit is DF, do not fragmented. That is, if it is 1, then fragmentation is not allowed. Then third bit, that is MF, more fragment to follow. If it is 1, then fragmentation is follow. If it is 0, then fragmentation is completed. Next, we will see about the fragmentations. What is fragmentation? Fragmentation is bisections of the fragment during transmission. For the better understanding, I will say in real-time example. For example, consider a money transaction. If you want to transact money, for example, I want to transact 1 lakh to some other person. At the time, I want to check whether I am having the availability of that amount. I have the bank balance of that. So suppose if I have 1 lakh, even though I have 1 lakh, I have to check the transaction limit. In this transaction limit, I have transaction limit 25,000, but I want to transact 1 lakh. For this, I have to split it, fragment into 4 parts, and I transact one by one. First, I will send 25,000. Again, I will send 25,000. Again, I will send 25,000. At last, I will send 25,000. At last, the transaction is completed. Maximum size of the packet is 64 bytes minus 1 KB. How the transaction limit is fixed in the money transaction. Similarly, the fragmentation is done based on the different LAN protocols in the data link layer. Here we have different LAN protocols, that is Ethernet LAN protocol, Wi-Fi LAN protocol, and then token ring LAN protocol. With this, different LAN protocols will help to fragment the packet. With Ethernet LAN protocol, that is the maximum transmission unit is 1500 byte, whereas in Wi-Fi LAN protocol the maximum transmission unit is 2312 bytes. For a token ring the transmission unit is 4000 byte. Next is network layer. In this network layer, it will generate the packet. That packet is transferred to the data link layer. The data link layer uses packet and generates the frame. That frame is forwarded to the physical layer, through channels. In network layer, in IPv4, the maximum datagram is 64 KB minus 1 bytes. Whereas in the packet is forwarded to the data link layer, the data link layer will transmit only 1500 bytes because it is based on the Ethernet LAN protocol. Ethernet LAN protocol maximum transmission unit is 1500, so it can transmit below 1500 only. Next thing, for example, consider the host 1 and router 1 and then host 5. In host 1 to router 1, the maximum transmission unit is 65,534 bytes. For its router 1 to host 5, the maximum transmission unit is 4000 byte. It will be differ based on the LAN of. Next we will see on real-time example. Consider a packet. In this original packet my data size is 1000 bytes, that is payload. My MF is nothing but a more fragmentation to follow. Then offset. Offset indicates the exact position of the fragmentations. Then ID is given as the identification number. Here I am giving identification number 578, offset is 0, MF is 0, data is 10,000. After fragmentation, here the data is same 578 because we already said the fragmentation data should contain the same ID, then only we can able to find the original packet. The next offset is 0. Initially it will start at the location 0, so the offset is 0. Next thing is next, here I am using 3976. Why I am using 3976? 10,000. Data header is, we already know that 20 bytes. The remaining are the 3980. 3980 are the data packets. In 3980 is not divisible by 8. So I am reducing 4 bytes. That is 3976. So here I am using 3976. So the last bit of this is 3975, which is next I found the offset. Offset is nothing but 3975 divided by 8 is the offset, 497. If you multiply 8 into 497 is 3976. It started the fragmentation offset is 3976. Then next it comes up to the 3976 plus 3976 minus 1, till that it will get a 7951. Till now, till this fragmentation I transferred from 0 to 7951. Remaining also I have to transmit. For this 579 and then 9940 2005. How this 994 is? Similarly 7952 divided by 8, we will get 449. That is said to be offset of 994. At last we will transmit from 7952 to 999. If you add all the three, that is 0, 3, 6, 3, 9, 3975, 3976 to 7951. If you add all the three fragmented, you will get 10,000. These are the fragmented packets. Next we will move on to the previous year gate questions. The first question is, in an IPv4 packet, the value of HLS, that is header length, is 1100. Given in binary, how many bytes of options are being carried by this packet? We have to convert this packet into decimal. That is, first the given option is 40 bytes, second option is 60 bytes, third option is 12 bytes, fourth option is 28 bytes. The option is 28 bytes. We'll see how it is. Here HLN is given as 1100 in binary. We are converting this into decimal, that is 8 plus 4 plus 00 is 12. We already know this. To find the length of the header, which is multiplied by 4, that is 12 into 4 is equal to 48 bytes. We already know that in option field 28 bytes is fixed, that is mandatory. Here remaining data is called packets. 48 minus 20 is equal to 28 bytes. So the option D is answer. Next question 2. In an IPv4 packet, the value of header length is 5. The length is given directly, and the value of total length is 0048, which is an hexadecimal. How many bytes of data are being carried by this packet? The given as option is 72 bytes, 52 bytes, 64 bytes, and then 89 bytes. The option is 52 bytes. We will see how it is. The header length value is given as 5. That is, to calculate the header size, 5 into 4, that is 20 bytes. Total length of the field is given as hexadecimal, 0048 to the power of 16. Then 4 into 16 plus 8 into 1 is 72. That is hexadecimal. 4 into 16 to the power plus 8 into 16 power 0. That is 4 into 18 plus 8 into 1 is 72. We know that the total length is data plus header. From this we found the header length and the header size. By using this, we can calculate the data. Data is equal to total length minus header, that is 72 minus 20 is equal to 52. Next question is, in IPv4 packet has arrived with the first few hexadecimal digits as shown below. That is, it's given in hexadecimal 450005300005906 in the 16. How many hops can this packet take before being dropped? We have studied hops in the time to live, that is the TTL. Based on the TTL only, we can say how many hops it takes. For option is 30 bytes and then 59 bytes or 89 bytes or 90 bytes. The option is C, 89 bytes. We'll see how it is. See the IPv4, the first number represents the 4 bits. Every number represents the 4 bits. The first one represents the version and the second represents the IHL. The third represents next 2 bits represents the services. Next 4 bits represents the total length. And the next 4 bits represents the identification ID, and the next 4 bits represent the flags and offset, and the next 59 represents the TTL, that is time to live. From this we can calculate the hops. TTL, it is given in hexadecimal. First we have to convert it into decimal and then we find it. Otherwise we can find out in another way. That is, TTL is present in the third fragmentation, that is third layer. The third layer, first 2 bits, that is the first 8 bits are the TTL. The first row up to 8, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7. Up to this is the first row. 1, 2, 3. After this is the second row. And the 59 is the third row, first 2 bits, that is the first 8 bits. So we can find that is the 59 is the TTL. From this we can directly find TTL. TTL is given in the decimal, hexadecimal. We have to convert that into decimal. 15 into 6 to the power of 1 plus 9 into 6 to the power of 0 equal to 80 plus 9, that is 89. Next question, an IPv4 packet has the first few hexadecimal digits as shown below. Similarly, the same value is given. The above packet belongs to which protocol? We know that after this TTL only, we have the protocol. That is, the protocol is given as 11. It is given in hexadecimal. We have to convert it to decimal, and then based on this packet number, that is protocol number, we can find the TCP, UDP or ICMP, IGMP. We know that TCP is 6, UDP is 17, the protocol number for ICMP is 1, IGMP is 2. And thus after next TTL, next 8 bit is protocol 1111. It is given hexadecimal. I converted it into decimal, that is 17. Every protocol for 17, the TCP is UDP. So the answer is UDP. Next question number 5. Which can be possible header size in bytes if IPv4 datagram 20 bytes or 30 bytes or 50 bytes and 60 bytes. Here the option is 20 bytes only, or 20 bytes and 60 bytes, or 60 bytes only, or all the above. Here the header size can be in between 20 and 60 bytes, but we have to think that it is divisible by 4. The only 20 is divisible by 4, 30 is not divisible, 50 is also not divisible, 60 is divisible by 4. So 20 and 60 are the answer. That is first and the fourth, option B. Next question, an IPv4 packet has the first few hexadecimal digits as shown in the below. That is, what is data size of IPv4 packet for this number? That is 72 bytes or 92 bytes or 82 bytes or 59 bytes. The option is 72 bytes. Here they are asking about the data size. In order to find the data size, first we have to find the total length and then header size. Header size we can identify from this number. The total length also we can identify from this hexadecimal. For example, first one is the version, second one is the IHL, then next two is the type of services, and the next four is the total length. It is given in 005C. The total length is given in hexadecimal. We have to convert this into decimal, that is 92. Whereas in IHL is 5, we have to multiply by 4. 5 into 4 is 20. So the total length is equal to data plus header. Data is equal to total length minus header. That is 92 minus 20 equal to 72. Next question is, in an IPv4 datagram, m bit is 1, then the fragment is how much? That is, m bit is 1 means then there is more fragment to follow. If it is 0 means this is a last fragment. Here they gave it as 1, then it can be a first fragment or it can be a middle fragment. But it is not a last fragment, so we can say option both A and C. Which one of the following field of an IP header is not modified by the typical IP router? Because checksum, it will be identify the error occur in the packets or turbine frames or not. That is, so it will be modified based on the IP address. Source address will not modify. Time to live, every hop it will be changes. Length also may vary. So the option is B, source address cannot be modified by IP router. The next question is, the maximum number of IPv4 router addresses that can be listed in the record route. RR option field of an IPv4 header is whether it takes 9 IPs, 10 IP or 15 IPs or 6 IPs. Option field is maximum of 40 bytes. In that 40 bytes, 2 bytes is reserved. Remaining it have 38 bytes. For 38 bytes, one IP address contains 32 bytes. Among this 38 bytes, it can hold only 9 IPs. Next question is, an IP datagram of size 1000 bytes arrives at a router. The router has to forward this packet on a link whose maximum transmission unit is 100 bytes. Assume that the size of the IP header is 20 bytes. The number of fragments that the IP datagram will be divided into for transmission is 13 fragment or 15 fragment, 80, or it is if IP packet is given as 1000 bits, that is 20 bits is allocated for occupied by header, then remaining are 980 bytes. For a maximum transmission unit is 100 bytes. In this 20 bytes is allocated for header, the remaining bytes are 80 bytes. The number of fragments is identified by 980 divided by 80, that is 12.25, approximately 30 number of fragments are required. Thank you. Thanks for watching. I hope everyone understands the concepts of IPv4 and fragmentation. We'll meet in the next section. Thank you.